In order to figure out the support reactions at point of contact at A, B, and C between the wall and the smooth pipe, as it supports a vertical load of 45 pounds acting downwards, we can start by developing our free body diagram. Now, for the free body diagram, we have to start by first identifying our reference point. That is, X is taken as horizontal and Y axis is given as vertical here. Next, we need to isolate our object from all the extra stuff. Since in the question it's mentioned that the thickness is neglected, so I'm going to draw the pipe as a line from point A all the way where the load of 45 pounds is being applied. Next, we need to list down all the dimensions because we will be utilizing this free body diagram to generate our moment equation. Afterwards, I need to identify all my external loads and the support reaction. We just have a single external load of 45 pounds that is making an angle of 30 degree with the perpendicular axis of the pipe, whereas our support reactions at A, B, and C, the reaction force is always normal to the surface. Since I have point A acting at a vertical line, our support reaction is going horizontally. Whereas point B and C, there is a point contact. So our support reactions are perpendicular to the axis of the pipe at point B and C. Once we have the free body diagram, let's go ahead and write our equilibrium equations. Now for the equilibrium equation, we have three for a two-dimensional system. That is summation of forces along the x-axis, summation of forces along the y-axis should be equals to 0, and the moment at any point on our free body diagram is equals to 0. So we can start with any one of these equations. However, it is recommended to pick an equation that have least amount of unknown. So if I do summation of forces along the x-axis equals to 0, I will have three unknowns of Ra, Rb, and Rc. However, if I do summation of forces acting along y-axis equals to 0, I will have only two unknowns of Rb and Rc. So let's go ahead and start with summation of forces acting along the y-axis equals to 0. So to start, Rb is acting at an angle of 30 degrees with respect to the vertical y-axis. So if I take the cos 30 function, it will project the RB along the y-axis. Now in this case, it is pointing downward, so that's why it is taken as negative. Similarly, RC is making an angle of 30 degrees with the vertical y-axis. Again, taking a cos 30 function is going to project it along the y-axis. But this time, the arrow is pointing upwards, that's why it is taken as positive. Next, we have our external force of 45 pounds acting downward. Simplifying, we can figure out a relationship between RC and RB given as equation 1 here. Next, let's go ahead and figure out the other two equations, which one we should go with. We already have seen that the summation of forces along the x-axis is going to give us three unknowns, so let's figure out the moment equation. Now for the moment, I can identify any point on the beam. However, since in my equation 1 I have the variables RC and RB, I don't want to introduce RA in that specific equation. So I can write summation of moment at point A equals to 0, and what it will do is it will eliminate the variable RA, since RA won't have any moment at point A as it is passing through point A. So to start, our external load of 45 pound is acting vertically downward and making an angle of 30 degrees with the perpendicular axis of the lower half of the pipe. Since the moment arm is already given along the axis of the pipe, let's go ahead and resolve our 45 pound into the two components by taking the cos 30 and sin 30 function, and then calculate the moment each one of them generated with respect to point A. So our 45 cos 30 have a moment arm of 36. That is the perpendicular distance between the force and point A. And this is going to create our counterclockwise moment. So that's why it is taken as positive. Next, our 45 sine 30 has a perpendicular distance of 8 inches with respect to point A, but this time it is going to create our clockwise moment. So that's why it is taken as negative. Next, I have RC. Since the moment arm is already given to us, that is 20 inch, so we don't need to resolve this force as we already have the perpendicular distance from point C to point A. In this case, it is also creating our clockwise moment, so I have negative RC times 20. Finally, for RB, we have to identify the moment arm here, that is the perpendicular distance from point B to point A. So to calculate that, we can utilize our trigonometric relations. We know that tangent theta is equals to opposite over the adjacent, and we are looking for the opposite in this case because that is the perpendicular distance between point B and A. So that distance can be calculated using our tangent function and coming as 8 tangent 30. Next, this force RB is going to create our counterclockwise moment as well. That's why it's taken as positive. Now, sum of all the moments will be equals to 0 to satisfy the equilibrium condition. Simplifying, we get our expression 2 here. Now, if you look at expression 1 and expression 2, we have two unknowns, RB and RC, and I have two linear expressions. So I can solve those simultaneously by plugging in the value of RC from equation 1 into an equation 2. Simplifying, we get our value of RB as 12 pounds. Now, once we have that 12 pound, we can go ahead and plug it back into an equation 1 and solve for RC. That is coming as 63.92 pounds. Now, once we have both the values of RC and RB, we can go ahead and apply our final equilibrium equation, that is summation of forces acting along the horizontal x-axis equals to 0. Now, to do that, here you can see I have RA that is acting along the x-axis in the positive direction. So that's why it is taken as positive. Next, RB can be resolved in its x component by taking the sine 30 function. This is also pointing towards the right. That's why it is also taken as positive. Finally, RC can be resolved in a similar fashion by taking the sine 30 function. It gives a projection along the x direction. Now this time it is pointing towards left. That's why it is taken as negative. Simplifying and plugging in the values of RB and RC in the expression, we get our value of RA as 26 pounds.